Yes, hi. How are you, everybody? How are you, ladies and gentlemen? Welcome to another session, another talk here in Riyadh Java User Group. We welcome everyone to attend our online sessions. Today, we have a special guest, Mr. Mario. Hi, how are you?
Hi, fine, thanks.
Thank you so much for accepting our invitation. I would like to firstly give a little bit introduction about Riyadh Jag. Riyadh Jag is like kind of newly created Java user group here in Saudi Arabia. So we've been running online sessions for the past like almost 5-6 months. So if you'd like, please join us in the YouTube channel. Our YouTube channel is Riyadh Jag, and also you can follow us in Twitter, X, Riyadh at Riyadh Jag. We also welcome any speaker around the world. You're most welcome. We are really proud and eager also to invite everybody to speak about Java, speak about technology, speak about software engineering, architecture. We welcome everybody. So today we are cooking for you guys a very special Italian pizza and Italian pasta as well. So we are combining different technologies, machine learning, Quarkus, and artificial intelligence. So we are putting all these ingredients with our guest and with our chef, Mario. So Mario is a frequent speaker, is a Java champion, is also a JAG coordinator. So he's very actively contributing to the Java world and the technology world. So we leave it now to Mario. Thank you so much, Mario. So go ahead, and the stage is yours. And I hope you guys enjoy.
Okay, thanks a lot. Yes, as you said, I'm among other things also the coordinator of the Java user group here in Milano, in northern Italy. So if it happens that you are around here, feel free to ping me and get in touch. I work for Red Hat. I'm the project lead of Druze, which is the rule engine of Red Hat, but I'm also into machine learning these days, of course, why not? And I'm also a contributor of Quarkus, with a special focus, but not only on the machine learning part, with also with the Langchain4j integration part mostly. During this talk, I don't know if we have a mean to gather question from attendees, but please feel free to interrupt me when you want. So let's keep this as a conversation as much as possible. Okay, so let's start this journey. So my idea here is to show not only the machine learning part, but also how and why you should combine this technology also with, for instance, rule engine or symbolic reasoning, and why this could be effective and useful. I'm combining these two technology again together with Quarkus. Quarkus is just the environment when all this technology will be mixed together. So why not machine learning at all? Okay, machine learning is an amazing tool. I believe on one side, I believe it's really great and impressive and surprising what it can do. No doubt about this, and it's super useful. Sometimes I'm also surprised by the kind of mistakes that it does. So it's understandable. I mean, machine learning under a very bottom mathematical point of view is just statistics on steroid. Okay, and when you only apply about your business is statistics, it can happen something like this, meaning that I don't know if you ever bought something on Amazon sometimes ago about washing machine, and of course since this thing is simply statistically related, then Amazon decided me to buy 3 more washing machine in a bundle. So they basically decided I was about to put up a laundry at home. I don't know why. Well, I mean, of course I'm joking. I know why. This happens because this application of Amazon is just applying the statistic correlation among all of these products, but not applying a very simple business knowledge that we all know, which is if I bought a washing machine last week, how likely is that I will buy 3 more this week? I mean, it's not very likely, right? This is something, a very, very, not only business, but very, very human knowledge that we know, but that we totally remove by only apply machine learning alone, by only apply the statistical approach alone, and forgetting about some very simple business rules. Okay, and another important aspect is that I believe there is a little bit of confusion on terminology. We use artificial intelligence and machine learning and sometimes deep learning in a very interchangeable way, but this is not the case, and probably it's better to use the appropriate terminology in this case. So in reality, machine learning is just a subset of artificial intelligence, where artificial intelligence at large is a part of the computer science that try to imitate the human behavior in a way or another. So it can imitate the human behavior because it has been instructed, taught to do so with a bunch of rules from a rule engine. It can be, it has been extracted to do so in a very programmatic way or in a statistical way with machine learning. And deep learning alone is another subset of machine learning when you use deep neural network and what today we call large language model, again, to mimic in a different way the human behavior. For instance, for the typical chatbot that you may want to deploy with an LLM. Okay, and name is important, but we also in our industry are used to give fancy name or change name to our stuff. So as I said, I'm the project lead of Druce, which is the rule engine of Red Hat. But if you say rule engine, it really sounds something from the past, something from the 80s. And in 2000, we started calling them production system. It sounded more professional at time, more enterprisey. And now with the advent of artificial intelligence, we started calling it symbolic artificial intelligence. But at the end of the day, they are just rule engines. So we are changing the name of this thing to make it more, fancy and trendy. But it's exactly the same thing. But why you may want to use symbolic machine learning, not machine learning in that case, symbolic artificial intelligence or symbolic reasoning, or in essence, why you may want to combine machine learning with a rule engine. Because as I said before, with machine learning, you find statistical correlation and discover new maybe new pattern that you were not imagining, and you can find even rules of your business that you didn't know before. But the reality is that it's on the other side, it's on the right side of it, this image, that the business knowledge of your domain lies. So you encode the domain knowledge of your business in proper rules, okay? And you can combine the two things. This is the bottom line, the general idea of this presentation and of this talk. You try in a way or another to combine the flexibility of a pure machine learning application and also the human friendliness, let's say, of a pure machine learning application with something that in a way or another encodes your knowledge of your of the domain. Okay, you don't want to throw your knowledge away and let it discover from scratch in a poor and statistical way from machine learning. It's something that you want to leverage because it's really your richness. It's the knowledge of your business. Okay, so in reality, what I'm saying here is not something completely new. There is actually a whole branch of artificial intelligence that studies and formalize this pattern. In general, here the fancy name is neurosymbolic AI, meaning that with this form of AI, we are trying again to combine machine learning and symbolic reasoning, and there are lots of patterns to do this. And as you can see, most of them have a fancy name, but except for the fancy name, they have very concrete use cases. And one that we will so there are many ways to combine machine learning and symbolic reasoning for different goals, for different purposes. The one that, for instance, we will apply in the demo later during the presentation is, in this case, the latest one in this list, where we try to combine symbolic reasoning to limit the possible hallucination of a chatbot made with an LLM. Okay, and the idea behind the demo that I'm going to present started from news that I read a few months ago. I think it was this spring. In essence, I don't know if you read this news, but in essence, what happened is that Air Canada had this chatbot in production, and the customer generally had took assistance from this chatbot, and one of them asked for a particular refund, and actually this customer, according to the policy of the airline company, wasn't entitled to get any refund. Okay, but at some point the chatbot started hallucinating, and the chatbot told to the customer that he was due with a refund of 650 Canadian dollars. Okay, so of course the customer asked for that money, asked for his refund. And of course, Air Canada say, look, this refund is completely out of our policies. It's not really due. But what happened is that at that point, the customer took the screenshot of the chat, brought them in a court, and the judge, of course, gave him right. So the judge say, okay, the chatbot is part of your website, is part of your business, is under your control, and if in a way or another a part of your business said that that refund is due, now it's due. And so what happened in essence is that Air Canada had to give those money to the customer, and of course the very day after they killed and shut down completely the chatbot to avoid a similar problem in future. Okay, so the bottom line is that LLM are amazing, but they can hallucinate, and the reality is that they will hallucinate. There is no way to avoid this. So the only thing that we can do is not trying to avoid hallucination because it's really not possible, and there are paper and mathematical demonstration indeed demonstrating that hallucination is part of how these LLMs work. So what you do is that you cannot really get rid completely of hallucination, but what you do, you have to deal with this situation and try to mitigate this in a way or another. And mostly the two ways are, okay, you pair the LLM with a second or a third LLM that will control each other and validate each other, or you take a more programmatic approach, once again trying to combine these machine learning technologies with some more established and more reliable technologies in order to mitigate the problem. Okay, in essence, you don't want something that can hallucinate this way to lead your business. And yes, as I said, it's not that we are not trying hard enough to get rid of hallucination, but there are demonstrations that is not really possible also under a mathematical point of view. Okay, and before going to the demo, let me clarify a few other problems that I see in the pure machine learning approach. First of all, one of the problem is the accountability. Okay, so if something goes wrong, who is the responsible? If you are in your driverless car, your car is guided by a complete machine learning robot. Who is responsible if this thing causes an accident? You are responsible as the owner of the car, or the car manufacturer, or the provider of the machine learning model. You don't know. I mean, there is also a hole in our laws at the moment. The legislation is not clear about this, but the problem is that you cannot really let a machine to decide, because the machine is not accountable. That's the thing. And other than not being accountable, it's only generally not transparent in its decision. And you really want transparency, especially in some cases. I mean, you want to know why a decision has been taken. Maybe it's the right decision, maybe the outcome is correct, but this is simply not enough. I mean, if you ask a mortgage to your bank cannot refuse you the mortgage because just because the machine learning algorithm say no. Okay, or at least they cannot tell this to you. It's totally unlawful. I mean, the bank cannot say, look, I cannot give you your mortgage because machine learning say no. It's not enough. You need and you want an explanation, and this is even more important in other fields. Let's say for let's think about for the medical field. Okay, the machine learning give you a diagnosis, maybe a negative one. You have to go through some very invasive cure, and you don't know why. Is this acceptable? I believe it isn't. And the other problem is that you cannot really understand why this decision has been taken. I mean, try to understand why the outcome of a deep neural network by looking at the weight, for instance, would be like slicing a brain of a human and trying to figure out how he takes decision looking at the different slices. It just doesn't make sense. Okay, and the third issue is probably the most interesting under my point of view. I mean, as under the point of view of a seasoned developer like me, meaning that you know, when you have a bug in your software, let's say you have an if condition and you have you put an or in condition in or instead of in end, you have a bug, so there is some malfunctioning. And you don't know what's going on at the beginning. Then you try to figure out, you try to debug, you finally discover the bug, and there is a problem. It's a problem that you can fix. You switch the end condition into an OR to another build and deploy, and you are done. The bug is fixed. Okay, so you have a misbehaving in your application, which is caused by a programmatic bug. You investigate and eventually fix it. Problem is, what you do if you have a malfunctioning in this kind of LLM application? It's not a bug in the common sense of the term. It's not something that you can debug and fix. As I said before, a malfunctioning, it's in reality something that you should really expect, because hallucination cannot be eliminated. So it's not only something that you can expect, but it's not something that you can track down, you can understand what's going on, that you can fix in a programmatic way. I mean, there is not much you can do. These things have malfunctioning, and you simply have to deal with this and try to mitigate the problem. But there is no such a fix like changing an end with an OR. As I said, one of the most common strategies that, okay, I have an LLM, which is the main LLM in my application, but I want to avoid hallucination. So what I do is I pair it with a second LLM or a third. So one has control on the other, okay? And in this way, I try to mitigate the hallucination, which in reality, it's something that people is starting doing. It has some sense, more or less. But when I saw this approach for the first time, it reminds me of a very old XML joke. They if you have my age, you remember that like 20 years ago or more, they said that XML is like violence. If it doesn't solve the problem, you are not using enough of it. Okay, and this seems to be the same thing now with LLM. I mean, LLM is like violence. You add even more LLM or violence, and at some point, the problem is fixed. My approach has been a little bit different. So once again, I wanted to create a chatbot for the that simulate the Air Canada use case. of course, in a much simpler way. So I have a chatbot made, of course, with an LLM that tries to gather the user data. But at some point, when he had to calculate the actual eventual refund amount, it hand over all the data that it gathered from the chat to the rule engine. Okay, so I have my business rules encoded. I have my business knowledge encoded in rules that I'm going to apply. Okay, and in reality, in this application, I used the rules. I used a rule engine for a twofold way. One, once again, is to calculate the refund amount. But the other is that I created a very simple state machine. So what I'm doing with this chatbot is, collecting data and then use the data to calculate the refund. And while I'm collecting this data, I'm going through different stages. In the first stages, I'm trying to collect and to extract the data of the customer, his name, his age, or whatever else. Then, when this first stage is finished, so I remain in this stage till I don't have all the data from the customer. And at that point, I can use a different AI service to a slightly different task. Now I have the data of the customer. Now I want to collect the data of the flight. Okay, and at the end of the day, when I also have all the data of the flight, I have all the data to compute the actual refund, and I can pass all those data to the other instance of the rule engine that is intended to calculate that amount. Okay, I have this example together with a few others in this project on GitHub. So if you want to give a look at it after the talk, feel free, please, and feel free, of course, to provide feedback. Let's give a look on how this works. Okay, so as I said, this is a Quarkus application. I hope you know Quarkus is the Red Hat framework, a web framework, and you can add lots of features to this framework in a compositional way, of course, bringing in other extension, what we call extension technology. So what I'm bringing here is the extension to use the rule engine, and then I have an extension for LangChain4j, which implemented the conversational part with the LLM. And since this LLM is served by an Ollama server, I also have this extension together with a few others, allowing me to do some CDI, to do the REST calls, of course, and so on. Okay, and here I'm configuring this chat in a very easy, straightforward way with the application properties. So here I have a few rules, knowledge base and session that I'm configuring declaratively here. As I said, this thing has a few different examples. These are the two knowledge base that are interesting for this example. This is for the knowledge base to calculate the refund. This is the one implementing the state machine that I mentioned it before. And then I have the LLM part. So here I'm configuring this Llama server. I'm saying that I'm using this specific LLM model. I'm giving it a temperature of 0 to make it as reliable as possible. I'm giving it a little bit longer timeout than usual because these things run locally and sometimes it takes time, and I'm enabling the logging. So that's all very declarative and very simple to be configured. Okay, so let's see how this thing works. So I have this chatbot. The things I can start the conversation with a simple hi, and here you can notice two things for the beginning. The first thing, of course, is that I'm a backend developer, so I really suck in doing front-end development. So it's not really nice to see. And the second is that it is taking a bit of time to reply, but this is because everything is running locally, as I said. So I'm not relying on an external service. I have an Ollama service running on my machine. Maybe I can show you this, by the way. Okay, these are all the models that I tried with my Ollama server, and as I said, for this example, I'm using this one. So this one, this is the model that my Ollama local Ollama service is using for this team. Okay, and everything is running locally. So what's happening here is that I said as I said, we are in a state machine. Okay, so we are in the first stage of the state machine, so which is the collection of the customer data. Okay, so what I'm basically doing is that I'm using this first AI service. So what you have to do if you want to implement this on your own is that you create just an interface and annotate it with this register AI service, and then you can put in an annotation the user message. So what this does is that it put the text that you write in the chat here in this template, and it create the user message concatenated this prompt with your input, and it tries to extract the data in this situation the customer data from the chat. Okay, so if you look at what this thing says, that it's as I said, it's collecting the customer data. So it's asking for my name and also my age. That's all. I can say my name is Mario Fusco. Okay. So what's happening now is that the system is trying to extract a customer object from this data. So if you look at the signature of this method, by the way, as I said, you just write this thing, and the implementation is created for you by the Quarkus LangChain4j integration. Okay, so what this thing is trying to do is trying to extract from the text a customer object. Okay, and the customer object is made of a first and last name and of an age. So this is why the system, the LLM, is asking me, okay, give me your name and age, because it needs to complete this information. Okay, so this time I'm only giving to it my name, but not my age. So let's see if we can check on the log what's going on here at some point. Okay, it's trying. What the LLM does is putting the data that it collects from the user prompt in a JSON, and this JSON is passed back to me, and I try not me, but the LangChain4j extension automatically tries to convert this data into the customer object. So it's correctly extracting my first name and last name, but of course I didn't say anything about the age. So this means that the customer extraction phase is not completed yet because the system has not been able yet to extract the complete data of the customer from the information that I provided. So together with my name, I'll also say I'm 70. And this time, what we expect is that the customer data should be completed. It has all the information that it needs. So it can transition to the second state. Okay, so I didn't show you the rules here, but as I said, there's a very simple state machine where I said, okay, if I don't have a valid customer in my session data, that then my statement of the state machine is extracting a customer, and if I have the customer but not the flight, I need to extract the flight, and if I have both, I'm finally able to calculate the refund. So this is the state machine that I implemented with rules. And of course, you can object that it's a bit overkilling to use a rule engine for a so simple thing. It's true, but these things grow very fast. So you may want to create a very complex state machine, and at that point, encoding it in a rule engine, it will make much more sense. Okay, but anyway, let's see what's happening here. So is finally have all my data as a customer, and then if you read it now, it transitioned in the second phase. What does this mean in practice is that since I'm transitioned in the second stage, I'm not using anymore this AI service, which is trying to extract the customer information, but I switched service, and now I'm using this other service, which is trying to extract the flight. Okay, so I'm very confining the task assigned to the specific AI service, because this is the right way to minimize the hallucination. Okay, you can have one single very generic AI service where you say, okay, collect in one shot the customer data, the flight data, the delay, whatever. But this increase a lot the complexity, and this also increase a lot the possibility of wrong result, of hallucination in practice. If you have the sort of thing that you can do, that I did in this demo, that I also suggest you to do, is having different smaller AI services, very customized, very tailored for a specific goal. Okay, so I'm changing the state of the state machine. I'm also changing the AI service that I'm using according to it. So this is why this thing now is asking me about my flight. I can say that I was on flight 22 and it had 4 hours of delay. Okay. So now this thing is trying to extract the flight. The flight is just this object with the number of the flight and the delay minutes. I said it was 4 hours, so it will be 240 minutes. Okay, if you can see that it extracted correctly the data here in the log. So what happens here is that I'm I have both the customer data and the flight data in my session. At this point, I can go and calculate the refund. This means that I can activate the second set of rules. These are the rules that I said I wrote to decide the refund policy of my airline company. So my airline company will give you a refund only if your delay in minutes is higher than 60 minutes. And in that case, you will have a refund of $2 for every minute of delay. Okay. So in this case, since I'm having 240 minutes of delay, you will have $480 of refund. Okay. Moreover, there is a second rule in my policy that said that if you are a senior, if your age is higher than 65, and if you remember, I told this thing that I'm 70. If your age is higher than 65, then you are entitled for a 10% more. Okay. So what we expect, what my policy is saying, is that I should have $480 plus the 10% according to my airline refund policy. So in essence, I should have $528. Okay, which is exactly this thing that is telling me. Okay, so this is telling me this not because of a fancy hallucination, but because the LLM is going and applying the rules that I encoded in my withdrawals. Okay. Moreover, when I wrote these rules, I also said I also add an explanation. So when these rules fire, I append to the refund amount an explanation to say why I'm giving this refund, and the same thing in this case. Okay. So what I can also do now, I'm saying that by combining the LLM with a rule engine, I'm not only making this thing more reliable, but I'm also making it more transparent, meaning that at this point I could maybe ask, explain why I got this refund amount. Okay. And now the LLM should use rules to extract an explanation, a human understandable explanation of why I got this refund. Okay, so let's see. This generally takes a little bit more of time. Okay, but as you can see, he's telling me that I got this refund exactly why I told you. I'm entitled of $2 of a refund for each of the 40 minutes, the 240 minutes of delay, and since I'm a senior, I will have a 10% more. Okay, how did this thing do this? Because now I'm in another state. In this state, I'm using this other AI service, and this I configured this AI service to use an external tool. So I instructed this thing with a system message to say, okay, if the customer asks for an explanation for the refund amount, then you delegate this explanation to the tool. Okay, so what this thing is doing is calling this tool. The tool is extracting the explanation from rules, from the refund amount data. So is the explanation that I added in the rules while the rules are fired. This thing is passed back. So what happens is that the LLM called this tool returns a string, and the string is then manipulated to the LLM to make it more readable, more understandable under his point of view. So it's not return exactly the string, but as you can see, it's adding stuff. It's adding more stuff to it, rewriting a bit the explanation, but the explanation is the thing that I provided transparently and accorded with my refund policy through the business rule. Okay, and this completes my demo. Is there any questions so far? Okay, I will probably take the question at the end. Okay, and of course I saved a screenshot of this interaction because you never know what's going on with LLM. Probably sometimes it works, sometimes it doesn't. So at least I have the evidence that sometimes it works. And in reality, what I did is that okay, I really believe that. As I said, LLM and rule engines are really complementary technologies. So what I also did partially for a joke is asking directly to ChatGPT, how would you combine your capabilities with a rule engine? Okay, and it provided me a very meaningful list of use cases. The very first one is the one that I also showed you, is the customer support chatbots, but there are a lots of other meaningful ones. For instance, another one that I found very interesting is the number 9, the smart home automation. You may want to interact with your smart home appliances through an artificial, machine learning chatbot or something like this, but also you don't want this thing to hallucinate and I don't know, to turn on the heater in summer for any reason. So you can control this thing with a rule engine in a proper way. Okay, and there are lots of other nice example how this combination could be useful and meaningful. So another thing with which we are experimenting, it's related to the nature of these two tools. Okay, so if you think about it, a rule engine is something that takes in input data and rules and provide answers, while a machine learning algorithm is something that it takes in input the data and the expected answers, and after training phase, it is using the expected answer given the data. It generates some rules in a statistical way. Okay, so if you think about it, these two things could be combined in a loop. So you can have a machine learning that generate the rules and formalize the rules, and then these rules could be applied in a more faster, cheaper, and transparent way by a rule engine. So we tried this approach, and again, this is another form of hybrid artificial intelligence. It's another field of research. And we are doing this because we want to leverage the strengths of both these technologies. So we want to use the high adaptability and human friendliness and the possibility of manipulate complex and amount of data in a very flexible way of machine learning, together with the speed and reliability and the interpretability of a rule engine. And the interpretability of a rule engine it's supposed to cover the lack of interpretability and the data dependency of the machine learning, and the flexibility of the machine learning is supposed to compensate the lack of adaptability of a rule engine. So as you see, these two technologies are really complementary. One covers the strengths of one, covers the weakness of the other, and vice versa. So we tried to combine again these two technologies in the way that I'm saying. What we did is try to generate the rules, business rules, from a set of data. Okay, and to do this, we used. There are a few possible approach to solve this problem. The one with which we experimented with is this algorithm that is called 1R. 1R stands simply for one rule, meaning that this algorithm works on iteratively on one rule at a time, creating extracting rule from the data. Okay, so we started with this data set, which is supposed to diagnose diabetes in earliest stages possible. And we took this database from Kaggle, and it comes with a lots of different features, exploring the relationship between that feature and the diabetes, the possibility of having diabetes. But we selected the 3-1 with the highest relationship, and we feed it these three features to that and the result to that 1R algorithm. So what this thing does is iteratively creating this rule in automatic way. Okay, so we are not writing this rule by hand. This rule are written by the this 1R algorithm approach, using the data, the statistical correlation generated by the machine learning. So we have a first iteration when we generate, for instance, this rule one after the other, and then we check how much this rule are covering of the data set, and how many error these rules are producing, comparing their result with the expected result. And then you can again iteratively add more rules with this approach, or you can eventually not only add rules, but also delete a rules and create a new one, or modify an existing one by adding one more constraint. Okay, and in this way, as you can see, you go from 15% of error to a 7% and go on, and you continue creating new rules up until you reach an acceptable threshold of errors. Okay, this is how this thing works, but again, this is much more, let's say, experimental than the demo that I showed before. Okay, and so we reached the end of my presentation. So just a few quick takeover. Once again, I believe that names are important, and machine learning is only a fraction of the artificial intelligence story. Once again, artificial intelligence means mimicking in an artificial way the human intelligence. That's it. That is generally what we used to define for artificial intelligence. And there are different ways for achieving this goal. One are deep neural network, and the other are programmatic one, or using a rule engine, as in my case. Okay, and once again, the other message that I hoped I passed through you is that machine learning are not really replacing symbolic reasoning or rule engines, but they are very complementary technologies, because once again, I believe that that they complement each other. Okay, I believe that they have very, very different features and characteristics, and if you combine them, as I try to do, you can take the best of both. And yes, this is, sorry, I'm going backward, and this is really what I have. Here you can see a few references of the thing that I presented today. And yeah, I'm done with this. I'm open to question if you want, or I can take offline other question or suggestion if you want, or I invite you again to download. I don't know if you took the reference of that project. Okay, if you want, give a look at this project and let me know if you have any feedback or suggestion to improve, of course. And that's all I have. Thank you.
Yeah, thank you so much, Mario. Such a very great effort, amazing combination, very good talk. We have here a couple of questions, if you don't mind. There's a question here. Like, I think you have come across this question. How can we control the hallucination? I think you mentioned that there's a couple of ways to control the hallucination, right? So from your experience, yeah.
So one technology that we have in Quarkus is what we call the guardrails. Let me check if I can find this thing quickly. Quarkus guardrails. So if you, sorry. Okay. If you look at this page of the Quarkus documentation, this is the documentation of the Quarkus LangChain 4J. This is something on which I'm working these days. That this technology again is called guardrails. In its, how can I say, a way to validate and convert, if you need, both the user prompt and LLM response. So you have this bidirectional thing. You have what we call the input guardrails. With these input guardrails, you can prevent, for instance, what we call prompt injection. Okay, you can probably try to detect a prompt injection, for instance, and avoid that the malicious user prompt could hit the LLM at all. And I have another example of this thing that is also using. It's not here. So this is a part of a talk that I did the Devox last month together with Lisa Rice, who is the main maintainer of LangChain 4J. For instance, here I have an input guardrails, okay, and sorry, the input guardrails is this thing. Okay, so this is the input guardrail. that just implement this interface and have this validate method to say if in this case to detect in this case if the user message is malicious or not, and this input guardrails is injected here. So I'm saying that this AI service is guarded in input with this guardrail, okay? And what this guardrail does is using a second LLM. So this is the use case where I say you use one LLM to control the other. In this case, in reality, I use one LLM to control if the user prompt is malicious or not. So I have this input sanitizer service, which is implemented again with a second LLM that basically is provided with a few examples to decide if an input is malicious or not, and with a score. So this thing at the end of the day takes the user prompt and provides a score. And in my case, if the score if greater than 0.4, I decide that the input is malicious, and I block the user prompt. I blocked the input, and I prevent this thing to reach the LLM. So this is the input guardrails, and there are other example for the output guardrails. So of course the output guardrails are in the opposite direction, and this is mostly to prevent hallucination. So what you do is you try to parse in some way, maybe with another LLM, or you have some rules. You try to parse in some way the output of the LLM, and you may decide to avoid that response to hit the user. You don't want to, and you have a few things that you can do. Okay, you can say that the guardrail the value is fine, or you can say okay, it's fine, but before saying it's fine, you rewrite. And there is a very good use case for this. I will come to this quickly. Or you can say that it failed, so you don't want to propagate it, or that is fatal. The difference between fail and fatal is that you can have a chain of guardrails, okay? So you can have not only one validation, but more than one. Fail, say, okay, this failed for me, but continue the chain and then eventually collect even another error in the chain. Fatal, say, this is a fatal error, don't do any, block the chain completely and file with an error. And then you can say it's fatal, or you can say it's fatal, but you can retry once again with the same prompt, because you give the same prompt twice to the LLM, and probably the second time you have a second result. So you can say please retry with the same prompt, and you can say you can configure how many retry you may want, or you can say please retry with a reprompt, meaning that do retry, but not with the same prompt as before. I'm programmatically rewrite the prompt to try to convince you to produce a more meaningful and educated result. And the use case for this is something that I added recently, because we want to say, okay, it's pass, but it's not really good as it is. I want to rewrite the result before passing it downstream. What is the very common use case for this? What we do, let me check if I can find some log here. Okay, do this. Let me kill this and see if I can. No. Okay. So in this case, okay, this is the thing that I'm extracted. In this case, the LLM is producing the JSON that I expect. And what happens is that then internally, as I said, we take this JSON and we deserialize it, and this is how this thing does the extraction, right? But what happens very, very often is that the LLM reply not only with the JSON, but the JSON plus some hallucination with some fancy explanation. Let's say the age is 18 because you just became adult. So the JSON is okay, and then you have some comment that, of course, make the serialization of the JSON totally impossible. Okay, so before passing that JSON downstream to be converted into an object and then used by the rest of your application, what we could do, it's sanitization of the JSON, and we have an example here. I added this guardrail that now is provided out of the box by Quarkus, so you can simply extend this thing, and what this thing does is trying to deserialize the response, and then if the serialization is okay, so at the first shot it returns the result. Otherwise, it tries to programmatically trim the non-JSON part from the response, okay, to remove that hallucinated part that I was mentioning before, and then it tries to deserialize this result again, and if it succeeds, everything is fine. And if it also fails, it tries a reprompt, so it tries to interrogate once again the LLM, asking for telling him, look, the JSON you provided is not really valid. I cannot extract a reasonable JSON out of it. Please make sure to reply in JSON format. So this is, again, it's an empiric solution to cover with the hallucination problem. It works in many cases. It's very useful, and it's very easy to implement. It's very easy to write a guardrails and then you annotate the AI service with that guardrails, and it works out of the box. So in, again, 90% of cases, this is the solution.
Nice, amazing. Yeah. Very smart way to handle the hallucination. Very good, very good. So let's take the other question, if you don't mind. Now let's now we are in the Java world, so maybe some of us are not using Quarkus. So if we are using Spring framework, so is it like equivalent to use it Spring AI? Is it like the same using Spring AI and versus Lang4j, or they are totally different thing to achieve the same thing?
Yeah, unfortunately, there are quite. They are the same tool, but with different programming model, different set of annotation. The fact is that LangChain4j is becoming the de facto standard in the Java world to interact with an LLM, and that's why Quarkus integrated LangChain4j. Spring AI decided to take a different direction, so they are not integrating LangChain4j, but they developed their own integration layer directly with the LLM server. So at the end of the story, probably the feature is similar. The fact is that Quarkus is following a more standard way. Again, I believe that LangChain4j is becoming the standard de facto, while Spring AI developed their own model. And there are a few tools that at the moment Quarkus is providing, and very likely Spring AI is not. For instance, these guardrail things, I don't know if it's also available in Spring AI. I don't think so.
Yeah, sounds good. Yeah, very, very interesting. So is there any like production example for using Quarkus with Lang4j plus rules, like from your experience?
I'm not aware of anything that is in production right now. I presented this use case a few times now, and I received quite interested feedback. For instance, I gave this talk a couple of weeks ago here in Milano at a conference, and I've been reached by a few people working in an insurance company, saying that they have a very, very similar problem, and they didn't know how to do this, and now I'm in contact with them because they are trying to follow this approach. There's a shipping company in Northern Europe, in Denmark, that are following us. That I'm also in touch with them, trying to help them to implement this approach. So this stuff is very new, let's say, also experimental. We are creating right now the pattern to make it work. But no, I'm not aware of anything that right now is in production. I'm aware of a few companies working on this right now.
Nice. Yeah, I'm sure that it's going to hit the market in a really big like it will impact the market, of course. Yeah. It's really, so many big companies really require, already they have this business rules, and they want to integrate this with the AI. Of course, it's gonna be a very good match. Amazing. So now maybe there is a question by the new starters for Java engineers. They want to get into the world of AI, Lang4j, and ML, and this stuff. So, what's your best advice for them to go? What's the proper roadmap for them to go and achieve this goal?
Yeah, it's hard for me to give. I mean, I'm also very new to this thing, okay? So I'm not sure if I can give advice. I'm not even sure if anybody can give advice on this thing, because we are still in a very, we are all in a very experimental phase. I mean, meaning the whole IT ecosystem. We are playing with this stuff, but we really don't know in production how to use this thing properly, or how not abuse of this thing, which is another problem. I can tell you my personal experience with this. So in reality, I didn't know anything about this thing till exactly 1 year ago. 1 year ago, meaning at Devox 2023, I met Lisa Rice again, which is the LangChain4j maintainer, and I discovered this new world. So I started playing with this. I installed. So I started, of course, using ChatGPT. And then I wanted to not relying of ChatGPT. So so the very first advice that I can give you is install an LLM server locally and play with it and try with different models. So you can, for instance, use Llama, and which is the server that I'm using, and it comes with lots of okay, you can download it, but there are lots of model. Well, there are many models that you can try. So they are here. Okay, so there are lots of model that you can try of different sites. You can install them locally and play with them, as I did with Quarkus. Is very easy if you download my application, for instance. But there are lots of examples on how we integrate this stuff into Quarkus. So I started doing this. I started, and at that point, when we as the Quarkus team saw this presentation of LangChain4j, we started this Quarkus integration, and I was one of the first contributor to this thing. So I did a sort of learning of the job, learning how this stuff work, and contributing to the Quarkus integration for this stuff while working. And the things on which I'm experimenting is that now I'm working this day is the next step, because this year, so the last year most relevant presentation to me at Evox was this LangChain4j1. This year, I've seen this presentation on JLama, which is the Java equivalent of Ollama. Okay, so instead of having an external server that you interact with via REST API, you can have the Java inference directly in your virtual machine. Okay, and so you are not interacting with an external server via REST, but the LLM inference run embedded in the same virtual machine together with the rest of your application. So you don't have any external invocation. And these have a lots of nice use cases. For instance, we believe it could be useful for edge computing, because in this way you can have a self-containing application that contains your code and the LLM code, the LLM model in one single jar that you can deploy, and you can put, for instance, on an edge computing device. You, of course, is more performing because you don't have to. It's all embedded in your virtual machine. You don't have an HTTP request for each and every interaction. It could be safer, more secure. Once again, because everything it's in the same process. You don't have a REST call, and there are a few reasons to do this. Okay. So what we did is we also implemented JLama extension. So you can use LangChain4j instead of using LangChain4j with Ollama. You can use LangChain4j with JLama and have this thing running in the same virtual machine. And this is the thing I'm playing with this. And by the way, if you want to give a look at how this works, in this project, there is a branch called JLama. And if you use this branch, now instead of using Ollama, it's using this chat model made with JLama, and instead of interacting, you don't have to install an external server at all. If you want to do this, you don't have to install Ollama. Everything is already configured. You start your application. At the very first run, JLama will automatically download this model. Or as you can see, I was experimenting with a lot of them. These are commented out, but I was experimenting with a few models. What happens with this approach is that you don't have any external server again. So this is also nicer, for fast prototyping, because it's up and running. It works. You don't have to install anything else. And what happens is that when you launch this thing for the first time, JLlama will automatically download this model from Hugging Face, and it works. You don't have to do anything else. So this is the last thing on which I'm playing this day, and I'm contributing to the JLlama project. First, to improve a little bit the performance. It works very well. The only warning is that this thing is using the vector API that is not yet in a stable release. So you need to do. Let me check here. You need to. Okay, if you download this thing, it's already done for you, but you basically, when you launch the Java virtual machine, okay, if you launch this project, it's already done in the POM configuration. But if you launch, for instance, the jar, you need to launch the virtual machine with this option and this, because you need to enable the vector API, which is still in a preview stage on the latest JVM. I believe it will be for sure it will be still in preview for Java 24, so the very next Java. It will be very likely stable in Java 25. So let's say September 2025, we should have this vector API stable, and at that point you don't need to do this anymore. You don't need to enable any preview. So once again, even this stuff, as you can see, is very experimental. It's relying on experimental features of the Java virtual machine, and it has support for a few models. Since I'm working with IBM Granite model, I send a pull request to the JLlama project to plug the LLM inference for that family of models. It's everything in early stage. So again, this is my path, my experience, what I'm doing so far. But I believe that everybody has its own different and very personal path to this.
Yeah, absolutely. Thank you so much. I think, Mario, I have really also other many questions, but I really don't want to take much of your time and also the session. Maybe let's close it with the last two questions, if you don't mind. The first question is that, do you see that the Java world is always lagging behind when in terms of AI? Because if we see the Python world is always is done this lang chain initially happened like 4 or 5 years maybe ago, and the Java is just lagging for just recently, maybe 2 years ago. So from your experience, do you see that learning Python for Java engineers would be who are also interested in the AI will be also a good option for them, or we can forecast now the future that Java is going to enrich the libraries and the stuff regarding the AI?
So it really depends on the kind of work that you want to do. I mean, if you are into data science, what I'm doing now it's using existing model. I can do some fine tuning, I can do some RAG, but at the end of the day, I'm not creating my own model. I'm using existing model. Okay, so I'm an engineer who is integrating these technologies with the rest of the existing application and try to provide pattern and facilities for others to leverage my job and using, for instance, the Quarkus extension, the guardrails, or this Gelama integration, whatever. Okay, but I'm not creating my own model. If you want to be a data scientist, if you are into, I want to create my model, I want to play with data. Okay, let's be clear. I'm afraid that there's no way to avoid Python. Okay, you really need to do Python if you want to follow that career path. I mean, all the data science, Python is the lingua franca for all the data science, and you need at some point to I don't know. The minimal is using a Jupyter notebook, so it's Python. Which is, by the way, just a nice DSL on top of C, because this is what Python is in this context. Is everything is written in C, including PyTorch. PyTorch is just a nice DSL on top of a bunch of C library, of course, because if you try to run this stuff in pure Python, it will take forever. It will take hundreds of times more, so it's not really effective. So Python is the lingua franca for this stuff, mostly for the nice mathematical feature. And so, again, if you want to be a data scientist, there's no alternative, I believe. I'm not, I don't know. I mean, I know just a little bit of Python, but because I did a different job in parallel, which is related with Ansible, which is also written in Python, but has nothing to do with machine learning. I don't know. Basically I don't know anything about Python. Okay, so I'm doing this stuff in pure Java because I decided to stay on the engineering part. I mean, being a data scientist is not my job, and I'm not good at it. And you need lots of mathematical background, so it's not something that you become a data science in a night. Okay, so it's an amazing career. I'm invite you to follow it if you are into it, but it's not my job. And again, if you just want to use models, not creating new one, you don't need Python.
Okay, yeah, I got it now. It's very clear now. Very clear. Yeah, thank you so much. Last question is that now we have the AI agents. It's called
Sure.
digital assistants and AI agents. So this also can be done using the same pattern that you are demonstrating to us, right? Using Lang4j and this stuff.
Yes. The other part, missing bit of agent is that what you normally do with agent is that you coordinate more LLM or more function together. So you have, let's say, a workflow of interaction between programmatic function and different AI service that you combine together again in a single workflow. There's another project in Python that does this, which is called the LangGraph. And there is the Java equivalent, which is called the Lang4j. So if you are into this, give a look at Lang4j in Java if you want to do this in Java. Otherwise, there is the original Python version, as it happened with LangJ. So it's this project. Let me check if I can find this. is this project, which implements the most common pattern for agentic AI. I'm really new to this as well. I'm learning these days also this part, playing with this. We are discussing how to integrate this part with Quarkus. At the moment, we don't have much, but as you can see, there are basically two contributors to this library, and one of the two is a redactor, is a colleague. So we are into this, and I'm talking with Alex these days to learn about this technology and figure out how to integrate this stuff into Quarkus as well.
Very nice, awesome. I think LangGraph is part of also Lang chain, right? It's
yes.
under the umbrella of Lang chain.
LangGraph is built on top of Lang chain. Yes.
Yeah. Sounds interesting. So very, very informative discussion. It's been now 1.5 hour, Mr. Mario. It's really, really nice. We want to prolong. I want to make it longer than this, but maybe.
Okay, I'm hoping that next time we can meet in person. So if you start, doing some in-person meeting, consider inviting me, and I will be happy maybe to come with a family trip and have and enjoy the place. Yes, so it will be great.
Sure.
And again, really if any of you happens to come to Milano, please feel free to get in touch.
Thank you so much. Here we end the session with Mr. Mario, and we thank him for this amazing talk. Really new technologies, new terminologies. It's all about AI. You know, the future now is everything is going towards AI. So thank you so much again, Mario. And looking forward really to host you again and again.
Okay. Speak soon, and thanks you all for having me. Bye.
Thank you so much. Bye.